Solving inequalities, learning intentions. Solve and graph linear inequalities. Write solutions in the right set, so n for natural numbers, z for integers, or r for real numbers. Success criteria: I can. Get x on its own using inverse operations. Flip the sign if I multiply or divide by a negative. State the set clearly: n for natural numbers, z for integers, or for real numbers. Graph correctly: closed dot for greater than or equal to, or less than or equal to, open dot for greater than or less than. For or, so real numbers, shade a continuous line with an arrow from the boundary. For natural numbers or integers, mark only the allowed whole number points. Check by substituting a value from my solution. Solving inequalities. Here are scales that show 10 greater than 8. So we can see 10 is heavier or lower than the 8. So 10 is greater than 8. Would the scales stay as they are if the same amount is added to both sides? So let's say we added 2 to the 10 to make 12, and we added 2 to the 8 to make 10. Would the scales stay the same then? Would the scales stay the same, say as they are now, if the same amount is subtracted from both sides? So let's say we minused 3 from the 10 and we minus 3 from the 8. Would they stay the same way? Would the left-hand side be lower than the right-hand side? Would the scales stay as they are if the mass on each side is doubled? So if we multiplied by 2 and multiplied by 2, would they stay the same? And would the scales stay as they are if the mass on each side is halved? So if we divided by 2 on the left and divided by 2 on the right. The answer to each question is yes. The answers to the 4 questions above illustrate 2 very important results for inequalities. So here are the rules for inequalities. An inequality remains true when the same number is added or subtracted from both sides. And an inequality remains true when both sides are multiplied or divided by the same positive number. And it's very important here to note that it only works if it's the same positive number, not if it's a negative number. Multiplication by a negative number. Consider again the inequality 6 is greater than 4. Multiply both sides by minus 2. So 6 multiplied by minus 2 is minus 12. And 4 multiplied by minus 2 is minus 8. And if we were to say minus 12 is greater than minus 8, this is false, because minus 12 is actually less than minus 8. This illustrates that the inequality sign must be changed or reversed when both sides of an inequality are multiplied or divided by the same negative number. So 2 is less than 5, but 2 multiplied by minus 2 is greater than 5 multiplied by minus 2. So 2 times minus 2 is minus 4, and 5 times minus 2 is minus 10. And minus 4 is greater than minus 10. So we can see that the inequality symbol was flipped. 8 is greater than 6. We know this is true. 8 is greater than 6. But if we do 8 divided by minus 2, and we do 6 divided by minus 2, we have to flip the inequality, because 8 divided by minus 2 is minus 4, and 6 divided by minus 2 is minus 3, and minus 4 is less than minus 3. So we can see the sign was flipped. If an inequality is multiplied or divided by the same negative number, the inequality sign must be reversed. Solve the inequality 5x minus 3 is greater or equal to 12, where x is an element of the natural number set, and graph the solution on the number line. So we start with our inequality. So 5x minus 3 is greater or equal to 12. We're going to follow the rule: letters to the left, numbers to the right. We grab hold of the minus 3, we bring it over the inequality sign, and it changes to plus 3. So we have 5x is greater or equal to 12 plus 3, and 12 plus 3 is 15. So we're going to divide both sides by 5 to get the x on its own. And 5 divided by 5 is 1, and 15 divided by 5 is 3. So you get 1x is greater or equal to 3. So x is greater or equal to 3. Now notice that we divided here by a positive number, so we did not flip the inequality. We kept it as it was. So x is greater or equal to 3, and x is an element of the natural number set. So this means x is greater or equal to 3, and this means x is an element of the natural number set. So natural numbers are positive whole numbers. And when we are drawing out on a number line positive whole numbers, we draw noses. So if you see an N, a capital N that stands for natural numbers, you want to think noses. We're going to draw noses. And the reason I've spelled it as N-O-Z-E-S is that we use this rule for integers as well. So if you see capital Z, you're also going to draw noses. So we draw out our number line, and we're going to put noses on 3, 4, and 5. So basically big dots. If you want to think about, they're like Rudolph the Red-Nosed Reindeer noses, and that's a handy way to remember it. So I like to do big red dots, but you can do it whatever color you want. So we put noses or big red dots on 3, 4, and 5 because x is greater or equal to 3. So 3 is included, and then 4 and 5. And then very important, we have an arrow to the right to indicate that all the natural numbers to the right of 5 are also included. So 6, 7, 8, 9, 10, 11, and so on. Notice as well that the inequality sign and the arrow are both pointing to the right. This will always be the case, that the arrow will point the same direction as the inequality sign. Example 2. Solve the inequality 4 minus 3x is greater than minus 5, where x is an element of z. So x is an element of the integer set, positive and negative whole numbers, and graph the solution on the number line. So we have our inequality. We follow the rule letters to the left, numbers to the right. We grab hold of the 4, it comes over the inequality sign, it becomes minus 4. So we have minus 3x is greater than minus 5 minus 4. Minus 5 minus 4 is minus 9. And now we're going to divide both sides by minus 3. Because we're dividing by a negative number, the sign has to flip. So minus 3 divided by minus 3 is 1, so we get 1x. The sign flips, and minus 9 divided by minus 3 is positive 3. So we have 1x is less than 3, so x is less than 3. So to graph it now on the number line, so we know x is less than 3, and x is an element of z, so x is an integer, so a positive or a negative whole number. So this means x is less than 3. This means x is an element of the integer set. Z, which stands for integers, are positive and negative whole numbers. So again, we draw noses. We draw noses for z, just like we drew noses for n. So we have our number line. So we have our noses or our dots at 2, 1, 0, minus 1, and an arrow to the left. Again, the arrow is pointing the same way as the inequality sign. We don't put a nose at 3 because we were told that x is less than 3. If it had said less than or equal to 3, then we could have put a nose at 3. Solve the following inequality and graph the solution on the number line. So 5 minus 2x is greater or equal to minus 7, where x is an element of or, so the real number set. So real numbers are positive numbers, negative numbers, whole numbers, fractions, decimals, and so on. So all the numbers on the number line. So we have our inequality, 5 minus 2x is greater or equal to minus 7. We follow the rule letters to the left, numbers to the right. We grab hold of the 5, it comes over the inequality sign to become minus 5. So we have minus 2x is greater or equal to minus 7 minus 5. Minus 7 minus 5 is minus 12. So next we have to divide both sides by minus 2 because minus 2 is stuck onto the x. And when we divide by a negative number, we flip the inequality sign. So minus 2 divided by minus 2 is 1, so we get 1x. The sign becomes less than or equal to. And minus 12 divided by minus 2 is positive 6. So we have x is less than or equal to 6. So x is less than or equal to 6, where x is an element of the real number set. So this first part here means x is less than or equal to 6. and this part here means x is an element of the real number set. So real numbers are all the numbers on the number line. So for this, we do not draw a nose. When we see or, we do not draw a nose. We do not draw dots. We draw a steering wheel and a road. So when you see the or, you want to think road. We draw a steering wheel and a road. So here we have our number line. And because this says x is less than or equal to, we're going to draw a big colored in full steering wheel at 6. So it's much, much bigger than the nose that we had in the previous two examples. So we have a big steering wheel at the number 6 and it's colored in. If this had said less than, we would have an empty steering wheel. So just an empty circle that's not colored in. Because it says less than or equal to 6, we have a full colored in steering wheel. Then we draw our road, and then we have our arrow at the end of the road. And again, notice the arrow goes the same direction as the inequality sign. So this means x is 6, it's equal to 6, and it's equal to all the numbers less than 6. So it's equal to 5, 4, 3, 2, 1, 0, minus 1, minus 2, and so on. But it's also equal to all the little numbers in between, so all the fractions and decimals that are in between the whole numbers. So that's why we have a big solid line for or to indicate all the numbers on the number line. Another example, 1 minus 5x is greater than minus 14, where x is an element of the real number set. So we draw out our inequality, we follow the rule, letters to the left, numbers to the right. The 1 comes over, becomes minus 1. And then minus 14 minus 1 is minus 15. So now we're going to divide both sides by minus 5. And dividing by a negative number, the inequality sign will flip. So minus 5 divided by minus 5 is 1, so we get 1x. And then our new sign is less than, and minus 15 divided by minus 5 is positive 3. So we have x is less than 3. So x is less than 3, where x is an element of the real number set. So x is less than 3. X is an element of the real number set. So again, we draw a steering wheel and a road for or. So we have our number line. We're going to put an empty circle now at 3, an empty steering wheel at 3, because 3 is not included because it says x is less than 3. So an empty steering wheel or an empty circle at 3. And then a solid road to the left and an arrow to the left. And notice that the inequality sign and the arrow are pointed in the same direction. If the inequality sign had been pointing to the right, our road and our arrow would have been drawn to the right.